Hello friends, I welcome you to my YouTube channel MacPM. So in this video we will solve a numerical problem which is based on the metacentric height and stability. So let's read the problem. A wooden cylinder of a specific gravity 0.6. So specific gravity of cylinder is 0.6 and circular in cross section is required to float in oil. So specific gravity of oil is 0.9. Find the L by D ratio for the cylinder to float. So we have to find length by diameter ratio of cylinder to float with its longitudinal axis vertical in the oil. So if this is the cylinder, then it has to float vertically like this in the oil. Okay, so that what it means. So L is the height of the cylinder, so this is L given in the diagram already, and D is the diameter. Okay, so first of all it has to float vertically in the oil. How will it ensure that it can float? So for that condition, metacentric height GM should be less than or equal to greater than or equal to 0. Metacentric height should not be less than 0. It should not be negative. So GM should be less than or equal to 0. So minimum it should be at least GM is equal to 0. Means at least metacentric height should be at G, center of gravity of this cylinder. If it is below, then it will be unstable, and if it is up, then it will be stable. But at least it should be 0 metacentric height. It should not be negative. Okay, so how to find metacentric height? So metacentric height GM is equal to I by V minus GB. Okay, or BG. GB or BG is the distance between center of gravity and center of buoyancy. Okay, so how to find these things? First of all, see, V is the volume of water which is displaced by a cylinder. So how to calculate that? First of all, here not oil, water, here it is oil. So first of all, specific gravity is equal to density of cylinder divided by density of water. So specific gravity of cylinder is 0.6 is equal to density of cylinder divided by density of water is 1000 kg per meter cube. So density of cylinder is 600, 1000 into 0.6, 600 kg per meter cube. Similarly, specific gravity of oil is equal to rho oil, density of oil upon rho of water, density of water. So 0.9 is equal to density of oil divided by 1000. So density of oil is equal to 900 kg per meter cube. So we have found these densities. Now, as per law of buoyancy, see, this cylinder is floating in the oil. Okay, so it means buoyancy force which is being offered by this oil is equal to weight of cylinder. Otherwise cylinder would have submerged in the water, completely submerged. Okay, so buoyancy force is cancelling the weight of the cylinder. So what is the buoyancy force? So buoyancy force is equal to weight of cylinder. Now what is the buoyancy force? Buoyancy force is equal to weight of water which is displaced. So it is equal to weight of oil which is displaced by the cylinder. So what is the weight of cylinder? So what is the air? It is volume into density into G. So if you put these values, then weight of cylinder will be pi by 4 and D square, okay, into L. This is volume of cylinder, pi by 4 D square L into 1000. Density of cylinder is now 1000, but density of cylinder was 600 kg per meter cube into G is 9.81. This will be equal to volume of water, weight of water, which is equal to pi by 4. Suppose water is, the cylinder is submerged up to depth h, then water displaced height will be also h. So pi by 4 d square into h into 900 into 9.81. This is weight of water. So 9.81 will be cancelled, pi by 4 d square will be cancelled, and this we will get from here, 2 zeros will be cancelled here. So we will get 6L is equal to 9H. So H is equal to 6 by 9 or 2 by 3 L. Okay, so H is equal to 2 by 3 L. So this is one relation we have found out. Now what will be the center of gravity of this whole cylinder? Center of gravity of cylinder CG from A, if you calculate from A, then AG will be height of cylinder divided by 2. So height of cylinder is L, so here L divided by 2, and similarly BG AB, center of buoyancy, distance from A, is equal to h by 2, small h by 2, which is 2 by 3 L divided by 2, so it will be L by 3. So if we find BG or GB is equal to AG minus AB, which is equal to L by 2 minus L by 3, which is equal to L by 6. Now what is the volume of water? Volume of water displaced by cylinder is equal to pi by 4 d square into h. What is the value of h? It is 2 by 3 L. Okay, so this is volume of water displaced. And what is I? I, moment of inertia of top view, is equal to pi by 64 d to the power 4. So now GM will be equal to I by V minus BG. So it will be equal to pi by 64 d to the power 4 divided by this will be cancelled, pi by 6 d square L minus this L by 6. BG we have already calculated. So from here you will get, if you simplify that, then you will get 3d square divided by 32 L minus L by 6. Okay, because d square will be cancelled here, where it will be 2, this will be cancelled 3, and this will be 32. So this will go upside 3, so 3 d square, pi will be cancelled with pi, 3 d square by 32 L minus L by 6. So for stable equilibrium, GM should be greater than or equal to 0. GM should be greater than 0, because GM at 0 will be equal to neutral equilibrium. So GM should be greater than 0. So see here, 32 d square, sorry, no, it is 3 only, sorry, 3d square upon 32L minus L by 6 should be greater than 0. Okay, so 3d square by 32L is greater than L by 6, or if you take 6 this side, then 18 divided by 32 is greater than, if we take L this side, L square, and D will come this side, down side, D square. So L square by D square is less than 18 by 32, which is 9 by 16, which is equal to 3 by 4 square. Okay, so L by D square is less than 3 by 4 square. So L by D should be less than 3 by 4. So this is our L by D ratio. We had to find only this value in the question itself. L is the, find the L by D ratio for the cylinder to float. So this is the L by D ratio. L by D ratio should be less than 3 by 4 for cylinder to be floating stably. Okay, so I hope you understood this problem. If you have any doubt, then you can ask in the comment section. If you like this video, then please share and subscribe to our channel. Thank you for watching.